Hello, this video is for Algebra 1 and it is Chapter 3, Lesson 1. It is titled Graphing and Writing Inequalities. The objectives for this lesson are to identify solutions of inequalities in one variable and to write and graph inequalities in one variable. Our vocabulary for this lesson is inequality and solution of an inequality. So who uses this? Well, members of a crew team can use inequalities to be sure they fall within a range of weights, and we'll see that example in example 4. So the athletes on a lightweight crew team must weigh 165 pounds or less. The acceptable weights for these athletes can be described using an inequality. An inequality is a statement that two quantities are not equal. The quantities are compared by using one of the following signs. Our first sign here that we have is this red arrow to the left. We verbalize that symbol by using the words is less than. For example, A is less than B. Our second symbol is an arrow to the right, this blue arrow here, and we verbalize it using the words is greater than. For example, A is greater than B. Our third symbol, it's kind of like a mixture of the less than symbol and half of an equal sign. We verbalize it using the words is less than or equal to B. Thus the idea of kind of including half of an equal sign, letting us know that it is possible that A could be equal to B, but it might also be less than B as well. Our fourth symbol is the greater than symbol with half of an equal symbol. We verbalize this symbol using the words is greater than or equal to, such as A is greater than or equal to B. Again, having half of the equal sign here, it is possible that A is equal to B, but it might also be greater than B as well. Our final symbol is an equal sign with a slash through it. We verbalize this symbol using the words is not equal to. For example, A is not equal to B. Why do we need inequalities? Well, with equations, we have where we say that something is equal to something, means that that one value on the left is equal to the value on the right of the equal sign. But in this example here, where the crew team must weigh 165 pounds or less, well, if they equaled exactly 165 pounds, well, that would work out because that would be 165 pounds or less, right? The equal concept being here. But if they weighed 160 pounds, that would still be okay because it is 160 is less than 165, so it would be less than. So whenever they don't necessarily have to be equal, or they have to be greater than or less than another number, that's where inequality symbols come in really handy. So now let's talk about a solution of an inequality. A solution of an inequality is any value of the variable that makes the inequality true. So let's look at a table here in example 1, and we're going to talk about identifying solutions of inequalities. Here we have described the solution of 3 plus x is less than 9, and they want us to do it in words. So test values of x that are positive, negative, and 0. And so our first row across here are 1, 2, 3, 4, 5, 6 different values of x that we're going to plug in and check and see if they truly are a solution. Do they create a true statement? And we'll see that here in the third row here where we end up with a statement. So let's go ahead and start doing that. What if x were negative 2.75? Well, 3 plus negative 2.75 is 0.25. 0.25, is this less than 9? Indeed it is, so that means that negative 2.75 could be a solution to this inequality. Next, let's plug in 0. 3 plus 0 is 3. Is 3 less than 9? Indeed, that is also true. So 0 is also a solution to the inequality. Next, we have 5.99. If we plug that in, 3 plus 5.99, well, 3 plus 5 is 8. And we have that 0.99 still. So we ask ourselves, is 8.99 less than 9? Indeed, that is true also. So 5.99 would also be a solution to this inequality. Next we have 6. If we plug that in, 3 plus 6, that equals 9. Is 9 less than 9? No, it is not. 9 is actually equal to 9. So since we don't have the equality concept in this symbol here, we're not saying 9 is less than or equal to 9. It's just 9 less than 9. So in this case, the answer is no. So 6 is not a solution. Let's try a number a little greater than 6, like 6.01. 3 plus 6.01 is 9.01. Is 9.01 less than 9? No, 9.01 is actually greater than 9, so it's not a solution. And then finally, let's try something just a little bit bigger than 6.01, or a little bit greater, actually. The numbers are the same size, so I'm actually talking about values that are greater than, not necessarily bigger. So 6.1 plus 3 is 9.1. 9.1 less than 9? Nope, this is a false statement, so 6.1 is not a solution either. It appears to be that if the number is 6 or greater than 6, it's not a solution. But if the number is less than 6, such as 5.99, 0, negative 0.75, think about it. What about negative 10? 3 plus negative 10. 3 plus negative 10 would be negative 7. Is negative 7 less than 9? That would be true also. So any number less than 6 is a solution. So the solutions of 3 plus x is less than 9 are numbers that are less than 6. Well, if you think about it, there could be many numbers less than 6. Basically, we could go to negative infinity and find more and more values that are less than 6. Not just whole numbers, but or integers, not just integers, non-decimal negative numbers, but also decimal numbers as well. All the negative decimal numbers, and actually any decimal number that's between 0 and any number less than 6 also could be a possible solution. So that would be a lot of numbers to list if we were asked to list all of the possible solutions. Well, there is a way that we can handle that. Actually, there's a couple ways, and one of them is to use set builder notation. And we have that over here. The solution of the inequalities in example 1 can be written in set builder notation. Let's go ahead and underline that right there. Set builder notation. You might be saying, well, what is set builder notation? Well, set builder notation is written with some braces, right? We have some braces here, and the braces are read as the set of. So the set of. Then I'm going to color code this, kind of like what they did down here with this and their explanation of it. And so the set of, and then we have this x here. So the set of x, and then after that, this next line here, this blue here, that vertical line that we see here between the red x and the blue x, this is read as such as, such as. So we read this as the red braces, the set of the green x, x, so the set of x, the vertical line here, such as, and then we would have x is less than 6. So we're talking about all values of x that are less than 6. In this here, it's called set builder notation because it's almost like the instructions for if you were to wonder what are some of the solutions if you wanted to build, if you actually wanted to build a complete set of all the possible solutions, you could use this. This would almost be like instructions on how to build the set. So it's set builder notation. Notation, a word that we use on the process of how we would represent something. And then finally, I'm going to go back to green. The textbook here starts off, they mention real numbers right here. And sometimes we'll actually see the classification in numbers that qualify, like maybe natural numbers, whole numbers, we have integers, right, so forth, rational numbers, irrational numbers, etc. And those are all different classifications in numbers. So you might be wondering, well, which numbers are we talking about? Well, in this case, we could make this further, we could clarify this a little bit further by putting a comma here, and the comma would be the word and then we would have this section right here. X is an element of real numbers. A little bit of notation there. This little E symbol here, right, we would read that as an element of, an element of, and then this little fancy looking R that I put in here, it has like 2 lines for the vertical part of the R, and then it wraps around like this. This here is the notation for real numbers, So I spent a little bit of time on this, just figured I'd throw in a little bit of lesson on set builder notation. If you see it, how do you read it? How do you interpret it? So again, if we see this, we read the brackets as the set of x such that x is less than 6 and x is an element of real numbers. Bonus stuff, right? Let's go ahead and look at the next slide here. How about another way to represent all the solutions of an inequality? We could use a graph. And an inequality like 3 plus x is less than 9 has too many solutions to list. You can't actually sit and write them all out. You can use a graph on a number line to show all the solutions, and we see that here. We see the 6 here, and everything to the left of the 6 is everything that is less than 6. The solutions are shaded, right? So all of these are possible solutions of the inequality. They're shaded with this line. And the fact that the arrow is shaded here lets us know that that line, that all those solutions continue to negative infinity, just like the left side of the number line continues to go to negative infinity. So the solutions are shaded, and the arrow shows that the solutions continue past those shown on the graph, such as past negative 10. To show that an endpoint is a solution, draw a solid circle at the number. To show that the endpoint is not a solution, you will draw an empty circle. So remember, 6 was not a solution, so it's an empty circle. However, if 6 were a solution, then it would be a solid circle. Now, for the sake of discussion and to fit my personal terminology and the words that I will use, what the book calls a solid circle, let me change back to red. I get distracted if I'm not using red. What the book calls a solid circle, I call a closed circle. Closed. So if it's filled in, like we see down here on these last 2 examples at the bottom here, such as at the 1/2, and at this 0 here, I refer to those as closed as opposed to solid. And then for empty, you probably guessed it, I call these open. Well, the opposite of solid is empty, and the opposite of closed is open. So I'm going to call those open circles. So this example up here, where it is empty, I would refer to that as an open circle instead of a closed circle. So with that out of the way, so you understand what I mean whenever I say closed versus open, you'll understand that I'm talking about either solid or empty. So let's go ahead and go on to graphing inequalities table here. In words, all real numbers less than 5. Well, here we have it in algebra. X is less than 5. So we'll find 5 on the number line. Here's 5. All the numbers less than, it's everything to the left of, and we go ahead and highlight all the way to the arrow so that we know even the numbers past negative 4 are also solutions. And in this case, we don't have the equality concept built into our inequality symbol here. There's not like half of an equal sign, so therefore it cannot be equal to 5. So 5 is not part of the solution, therefore it is an open circle. Next one, all real numbers greater than negative 1. X is greater than negative 1. And I find negative 1 on the number line. Here it is. Everything greater than it is going to be to the right of the negative 1 on the number line. And I am going to highlight the arrow here to show that even all the values past 6 are also solutions. However, no half of an equal sign here, so that means that negative 1 is not a possible solution for this inequality. So I'm going to leave it as an open circle. Moving along, we have all real numbers less than or equal to 1/2. So x is less than or equal to 1/2. Notice the or equal to. This means that 1/2 is indeed a solution. We could plug that in, and if we substituted 1/2 for x, and we said 1/2 is less than or equal to 1/2. Well, that's true because we said or equal to. So then 1/2 is indeed equal to 1/2, so that'd be a true statement. So 1/2 is included. So I'm going to use a closed dot here, and then we're talking about all the numbers that are less than 1/2. That's going to be everything to the left of 1/2. Remember, highlight that arrow so that we know that all the numbers that go past negative 2 or less than -2 are also solutions. Next, we have all real numbers greater than or equal to 0. So x is greater than or equal to 0. Find 0 on the number line. Here it is. It can be equal to 0, so 0 is a solution. So let's use a closed dot. And everything greater than 0 is to the right of 0 on the number line. And again, highlight the arrow so that we know that all the values greater than 6 are also solutions to this inequality of x is greater than or equal to 0. Next, example 2, graphing inequalities. It says to graph each inequality. So our first one is b is less than -1.5. So let's find 1.5 or -1.5 on the number line. Well, here it is right in between -1 and -2. So we have -5. It's less than, so it's everything to the left of -1.5. We do want to show that everything less than -4 is also a solution, so we'll highlight that all the way to the arrow. And we'll leave it as an open dot because -1.5 is not a possible solution to this, because -1.5 is actually equal to -1.5. It's not less than -1.5. Here at example B, we have r is greater than or equal to 2. So let's find 2 on the number line. Here we have 2 on the number line is located here. It could be equal to it, so we'll make it a closed dot. And then we want to consider everything that is greater than -2, so that is to the right of 2 on the number line. Go all the way to the arrow to communicate that any value greater than 6 is also a solution to the inequality r is greater than or equal to 2. Let's go ahead and do a couple examples here. We'll do 2a. So on 2a, let's say that we had c and is greater than 2.5. So we would need 2.5 on the number line. We locate that. And then the shade, I'm going to go ahead and change colors over to green. Let's go ahead and make a dot there. Now, should it be open or should it be closed? Well, we don't have the equal part here, so 2.5 would not be a solution. So we want to leave that as an open dot. And then we're talking about greater than, so we want to shade, need a line. We want to shade everything to the right, and then also the arrow to show that all values greater than 2.5 are indeed solutions to c is greater than 2.5. Next, let's go ahead and grab another number line here. We'll put that up here. And now, as we look at our point that we need to graph, what should go here for this 2b? 2 squared minus 4 is greater than or equal to w. Well, first we have to simplify this portion right here. Well, we have enough information there. It's not like we have to solve anything. We just need to do the math, right? So let's do 2 squared minus 4. And what would that equal? Well, 2 squared is 4 minus 4. And so that would be 0. So right here for the left side, we're going to substitute in 0 because we've worked this out. See that 2 squared minus 4 is indeed 0 and greater than equal to w. So we would need 0 on the number line. Next, we need to go ahead and put our dot there. Should it be opened or should it be closed? Well, we do have the equal concept here, so 0 would work as a solution. So let's shade that in to show that that is indeed a possible solution. And then greater than, so it's everything to the right. So go ahead, go to the right, throw our arrow in there so that we show that it continues to positive infinity. Okay. Next, we have writing an inequality from a graph. So now it's just going the opposite way. In the last example, we had an inequality and we graphed it. Now we're going to be given a graph and we have to write an inequality for it. So with that said, let's go ahead and take a look at example A. Write the inequality shown by each graph. Well, we see here that our graph is at 4.5. It is an open dot, and it's everything greater than 4.5. So let's go ahead and say that, and we don't know, they're using the letter H. I don't know how we're supposed to know that, insist upon using H. I prefer X, so I'm just going to use X. So X, in this case, is greater than, is it open dot or closed dot, right? Well, it happens to be open, so it does not equal, the equality concept is there, meaning that 4.5 cannot be part of the solution of the inequality. That's a lot of words. And our value is 4.5. So x is greater than 4.5, and we see that they used h. On the next one, we are going to go ahead, I'm going to use the value x, even though they use an m. And now it's less than. It is a closed dot, so it could also be equal to. That's the key there. Notice that open dot does not have the half an equal sign. Closed dot, it does have half of the equal sign. And our value here is -3, and that's it there. X is less than or equal to -3 right here. Now, what Victor Salamas, I suppose is how Victor's last name is pronounced. He goes to Palmer High School. And he has a pretty good piece of advice. And Victor didn't have to tell me this. I noticed this long ago whenever I started working with inequalities. To know which direction to shade a graph, I write inequalities with the variable on the left side of the inequality symbol. I know that the symbol has to point the same direction after I write the inequality. For example, I write 4 is less than y. He flips it around to be y is greater than 4, right? They just change sides. The 4 goes from the left to the right. The y goes from the right to the left. And you have to reverse the sign as well. Or think of it this way. On this here, notice that the y, the open end of the symbol is facing the y. And then we flip it around and we keep the open end of the symbol facing the y as well. Now the inequality symbol points in the direction I should draw the shaded arrow on my graph. So I always encourage my students, later on we'll get into solving inequalities, a lot like solving linear equations, not much different. There's a few extra rules we'll throw in there. But if you solve it, and once you get it solved, your variable is on the right side of the inequality, flip it around, and then that way the arrow tells you which way the graph should go. And likewise, whenever we did these examples here on writing the inequality from the graph, because it goes to the right, I knew to go ahead and use a symbol that looks like an arrow pointing to the right. And on example B, since it goes to the left, I knew to use the symbol that looked like it's going to the left. Then the only other thing to do was determine should it be open dot or closed dot, right? And whether it should have the half of an equal sign or not. And then what number to put to the right. And the number to put to the right is whatever number is plotted on the number line. So having your variable on the right, like Victor says down here, is a big help in understanding which way the arrow on the graph should go. And then example 4, sports application. So let's go ahead and do the reading math over here. No more less than means less than or equal to. At least means greater than or equal to. So they say you can have no more than 5 pieces of candy. That means you can have less than 5 or equal to 5. You can only have 5 pieces of candy or fewer. And then at least means greater than or equal to. Today we're going to the amusement park. You need to bring at least $50. So that means that if you bring $50, that is equal to, or if you bring $100, well, you did bring at least $100. So kind of keep those phrases in mind. So the members of a lightweight crew team can weigh no more than, there's that no more than that comes up there, right? No more than 165 pounds each. And remember, no more than means less than or equal to. Define a variable and write an inequality for the acceptable weights of the team members and graph the solutions. We're going to let W represent the weights that are allowed. Good variable to choose. Weight starts with the letter W, so use the variable W. Good practice to get into. Pick a variable that kind of represents whatever it is that you want that variable to represent, especially if you're working with a word problem. So athletes may weigh no more than 165 pounds. Athletes may weigh, W for their weight, no more than, less than or equal to. Remember, we got that from our example or information over here in the reading math. And then 165 pounds will just represent as 165. So W is less than or equal to 165. Let's graph this inequality. Find 165 on the number line. Here it is here. Less than or equal to means our arrow is going to the left. And then we have the half of an equal sign, so we need a closed dot. And I was distracted there for a moment because I saw this right here. Notice the arrow is not shaded in any further. The reason for this is we stop the graph at 0 because a person's weight must be a positive number. You cannot weigh a negative number of pounds. So sometimes whenever we're dealing with real life situations and we're talking about inequalities, even though negative 59 is less than 165, right? Negative 50, or let's just say negative 60 because I forgot the number. Negative 60 is less than or equal to 165. But in this situation, we realized that negative numbers would not be reasonable. We could only go down to 0. Now, that means that 1 could be a possible solution, and I have a hard time finding the possibility of finding anybody that only weighs 1 pound. Even whenever you're born, you weigh at least, 5, 6 pounds, somewhere in there. So here we are at our guided practice, our vocabulary. How is a solution of an inequality like a solution of an equation? Oh, it has to satisfy the statement, right? In order for it to be a solution of an inequality, remember, whenever we had a solution of an equation, we had to get to the point to where that variable, if you plugged it back in, it satisfied the equation and made the equation true, that value truly made the left side equal to the right side whenever you go ahead and work it out. Well, likewise, anything that is a solution of an inequality, it makes the inequality statement true. And example 1 here, describe the solutions of each inequality in words. So in this case, we would say, I think that we have to plug stuff in. So I'm going to kind of skip this right now because this chapter is pretty much about understanding inequalities, being able to take an inequality and graph it, being able to look at a graph and write an inequality. And this here, we'd have to make a table for these. They expect you to make a table in later lessons. We're going to learn how do we actually solve these so we can find the solutions without a table. Notice that in this one here, we have the -5 with the G. Here we have the +1 with the H. Here we have the 5 tied to the T through multiplication. And here we have a +5 attached to this -x. And later on, we're going to look at how to solve those. And it's not going to be by using a table like we did in a previous slide of this presentation. And the fact that personally, I really don't have enough room on this page to do the table. And at 28 minutes into this lesson, I'm not going to go ahead and take the time to make the tables either. So let's go ahead and move along. And section 2 here, graph in each inequality. Well, we could go ahead and do an example on that. Let's go ahead and put our number line here. And then let's try C right here. Well, let's not 17. Yeah, let's go ahead and try this one over here. Let's try 9. This is a square root thingy. This might look complicated at first, but let's go ahead and simplify it. 17 plus 8 is what? 25, right? Square root of 25. Hey, we know that 5 times 5 is 25, so the square root of 25 is 5. Now, this one could be tricky because I'm guessing that they want you to go ahead, find 5 on the number line, and then go ahead and plot it. So we'll go ahead and put our circle there. And next, it is equal to. Notice the equal to concept there. So we want a closed dot. And then it's greater than. So we want to go to the right. So let's go ahead and take that to the right and put that there. Now, I would guess this is what they're expecting here. However, could we get, because in this case, I'm trying to see, because we know that negative, I better go back, get my pen. Remember, square roots actually have a positive and a negative form of the root. So if we did -5 here, that might be, I think they just want the positive version. So don't get too caught up in that like I am right now. All right. On the next one, let's go ahead and pick number 12. We're going to write an inequality here. So we're going to go ahead and take We're going to call this x. And which way is the arrow going? To the left. So we want it going to the left. Is it open dot or closed dot? Open dot. So I don't want the half of an equal sign. And what's the number at the point? It's 5.5. Amazing how easy that is, right? Over here, I'm going to pick this one because it's a closed dot, obviously. Actually, let's do 14. It's closed dot and it goes the other way. So here I'm going to have, for 14, I'm going to have x, right? It goes to the left. So make my symbol go to the left. And it has a closed dot. So it has the concept of the half and equal sign. And it's at 3. It's at 3. So x is greater than or equal to 3. Well, all these values represented by this shaded section here represent 3 and all numbers greater than 3. All right. So I'm going to go ahead and stop there on the guided practice portion. And that pretty much concludes my presentation of Algebra 1, Chapter 3, Lesson 1, Graphing and Writing Inequalities. Thank you.